So yeah, the filler control panel caught on fire. Not like a big dramatic fire with flames shooting out of the panel or anything. Just a couple of contactors that, when they were pulled in, they started to smolder and burn. Not a big fire, but just enough to set off the alarms. So now we're all standing outside in Dallas, Texas, in the middle of the summer. It's like 110 degrees out in the shade. Everybody's hot and sweating. Everybody's complaining that we're outside. And there's only a few people that actually know really what's going on. And I remember looking at one of the guys thinking, yeah, I mean, it's not a real fire. Like, come on. It's just, we've got this old 20-year-old plus filler that, it's just a little tired. And that pretty much summed up that entire project. Welcome to From the Bucket, where controls design meets reality. I'm your host, Keely Smith. In this podcast, we explore industrial control systems as they exist in the field, not just how they were designed in CAD or how they look on paper, but how they operated in a production environment, how operators and maintenance interfaced with them, and the fun and interesting stories that I've made throughout the years of being a controls engineer. So this project happened directly after the project that I talked about in episode 5. And I want to start there because that contrast really matters. And it's really what made this such a jarring project. So episode 5 was brand new everything, brand new machines, bleeding edge technology. Like, every single piece of equipment going on that line was brand new. Everything just worked. It was a really, really good line overall. And, you get a little spoiled working on something like that because everything's clean. Like, everything has intention around the way that it was designed. Like, when something doesn't work, that, there's probably something that you're doing versus having to question whether your hardware is actually solid. So then you move to the project that we're going to talk about today. So this is the same facility, same general concept. So we were doing a carton filler, but this time it was quartz. So the speeds were similar. I think in reality it ran a bit slower than the machines from episode 5, but it was still pretty fast. But everything else was really completely different. The idea behind this line was it was going to be entirely temporary. And that word, I'm going to keep saying it over and over because as we explore what this project actually ended up being, you're going to notice the irony in it as I continuously say, oh, but it was just temporary. Everything was temporary. This line was temporary. You're going to get really tired of me saying the words temporary. So I think it's important to actually define when you say something is going to be temporary in a food and beverage, like industrial environment. So typically when we're talking about a system that's going to be temporary, we're talking 6 months to a year. A lot of the times when I did these temporary lines, it was due to some sort of production push where there was a need to refill a stock, or maybe a new plant was being built, or just something to hold over some sort of production hiccup, or to get something that's could just be in place while a more permanent solution got in place. So the idea was that, when this line goes in, we just need it to do its job. It doesn't need to be realistically that good. It just needs to run long enough and well enough to get product out the door, because again, it's going to be temporary. So it didn't it didn't actually have to be that good. And because it was temporary, everything was used. And when I say used, I'm not talking like gently used. I'm talking like somebody scabbed together a whole bunch of junk, cleaned it up a little bit, and said, "Hey, we're going to make this thing work for a little bit." So there was some stuff that was newer, but you kind of get the idea, right? So we're putting together this used, really not very good line. So even when we talk about, like, we've got new equipment, just understand that this new equipment was as cheap as we could possibly find, because again, this was a temporary line. So the whole project advantage was that you could get this line up and running as quickly as possible, as cheaply as possible, and it fills this need. A lot of our lines, they started with the filler. The filler was kind of the thing that you would design the line around. So I don't actually remember where this filler came from. All I know is that it had been in production for something like 20 plus years. So here's the thing that was really different from most of these temporary lines where, we had these old pieces of equipment that had done, was this filler was actually being refurbished on site. And I don't remember why exactly this was, but it was kind of weird. And I think why that matters is, while this filler was being rebuilt, I was still working at this facility on a bunch of different lines, and I kind of had a front row seat to watching this whole process unfold of this filler coming in, getting torn apart, getting cleaned, from the first time that it got power at this facility, to the fire that mentioned in the cold opening here. That I got to kind of see this thing come together. You would kind of think that by actually getting to watch what was going into it, you would feel more confidence, right? Because you're actually seeing, like, yeah, they're going through every piece, and they're repairing things, and all, all of the right things that you would be seeing that would make you feel better. I I remember watching this process, and I just kind of understood, like, what exactly we were about to get into, because it was it was crazy. This was not like one of those times where you get to see it and you're like, "Yeah, cool." It was more like watching somebody put a band-aid on something that probably needed surgery. Um and knowing that when they actually finished putting this filler together and making all these repairs and everything, I knew that this machine that they were bandaging back together was about to become my problem. I think another one of the really jarring differences between this project and the project from episode 5 was, episode 5 was really that idea of chasing perfection in a processing line. And I think that it's important to kind of understand that mindset that I had going into it of I had just come off of this really technically advanced, really cool project. And, I was kind of already, I was in that mindset, but this line, there was none of that. This was, nobody wanted this thing to be perfect. Like I said, the directive here was basically just get it running, make it run well enough, spend as little time as possible on it, and that's it, because that's it. It's a temporary line, so the more time we put into it, the more time we wasted on it, because it's temporary. So why put all of that extra stuff into it to get it to that perfection state when in reality 80-90% was perfect. And I think the other part that was really interesting about this was, I was really fully responsible for this line. I remember running conduit with the electricians, pulling wires. I remember doing a lot of that other stuff. So beyond just the programming, testing, commissioning, and all of that stuff, I was part of like the front end stuff as well of working with the electricians. But that mindset was just totally different again, because we weren't building something that was supposed to be good. We were just building something temporary. And there's something worth saying here that when you're labeling everything as temporary, and that directive is to just get it done as quickly as possible, you really you create a product that you really aren't all that proud of. And it's not that anybody did anything wrong, it's just this is the way that we needed to run this project. And I think because everybody went into this project knowing it was going to be rough, I y- I think that there's a certain amount of cherry coating that you put in on a project. So like, yeah, you're sitting back in your shop and everybody's joking like, "Oh, yeah, this thing's going to suck." And you don't actually fully believe it. And you start thinking, "Yeah, you know what? It's not going to be perfect, but it'll be fine. We'll manage." But this wasn't one of those situations. This was where you're standing in front of this line and you realize, no, this project's actually really gonna suck. It's not gonna be fine. It's not gonna be manageable. And what we have to do here is genuinely going to be difficult. So fast forward a bit, and the line is mechanically in place. The filler has gone through the full refurbishment. The group is happy with the way that it's operating now. So here we go. Integrating the filler was rough right out of the gate. This wasn't a new machine where I got to sit down with like the OEM engineer and we define a clean interface together. This was more of a, here's the program. It's been running for 20 years. Make it work. Uh, there was really no figuring out an interface together. It was more of a, here, this is the interface that's in this machine. Make it work. And whenever you have 20 years of people going into a code and making their little changes, there's just chaos. Everybody likes to get into things, and they make these little tweaks, they make these little patches. They're making all these slight changes because they're making it better, right? But there's never any documentation there, and it just starts becoming this scab together thing. And the problem with that is it just takes a lot longer to work with it, because now instead of, again, just looking at like OEM code, you're digging through the OEM code, and then you're seeing where people have made changes over the last 20 years with no documentation. And then we moved down the line and there was this case packer. And this case packer, it was brand new, but it was cheap. And it ran like it was cheap. So it's probably worth mentioning that there was probably a bit of how we were trying to run this machine and how this line was set up that caused the problems, but this machine had zero forgiveness. So everything that you fed into this machine had to be absolutely perfect. It had to be perfectly spaced. It had to be perfectly oriented. It had to be perfectly flowing. If anything was off, this machines would just blow bottles up. And when I say it blow them up, I mean the cartons would get crushed in some sort of mechanics and explode. And the product would just splatter everywhere inside of this machine. So let me explain a little bit of what was actually causing this, because it connects to something that I had to learn the hard way on this project. Because what we're actually talking about is back pressure. So back pressure is just it's really just a fancy way of saying how many cartons you have lined up pushing against each other going into a machine. So if you think of it this way, if you take one carton and put your hand in front of it on a running conveyor, you can hold it. No problem. Now, when you start adding more cartons behind it, like 5, 10, 20, at some point, you're not going to physically be able to hold that pressure anymore. There's just too much force pushing it. And that's what back pressure is. So with this particular case packer, I had to be incredibly careful with how much back pressure I was building up, because too little and the machine doesn't feed right. Too much and the pressure alone, before the machine even did anything, was enough to blow up a carton. And like I said, when you blow this thing up, it's a big splattered mess. And it's not just that you blew a carton up, it starts a whole process now to actually clean that up. I remember the operators absolutely hating this line. And honestly, I never really blamed them, even a little bit. Because if you got assigned to that line for your shift, you were in it for a shift. This wasn't a pull up a chair and kick back sort of situation. This was a you're walking this line all night. You're listening for the weird sounds. You're looking for the weird things that just seem to happen on this line. You're just waiting for the next thing, because something always went wrong. And it was one of those lines where when it ran fine, it ran fine. But there were always the hiccups. The filler would jam, and that was outside of my line controls. So there was genuinely nothing that I could do here as the integrator. I just have to look at the operator and say, like, I'm sorry, I can't do anything for you. And then there was the times where the case packer would jam and we would have those cartons explode, which was just its own kind of just craziness. Because when that case packer jammed, the operators had to stop everything. They had to open up the machine. They had to first try to clear the jam. But the problem was, when this machine jammed, it seemed to always jam in the worst possible ways. Like, cartons would end up in all these crazy nooks and crannies where obviously they weren't supposed to be. And every time an operator would have to reach in and crank on something to get the carton out, and they always were at risk of bumping something, pulling something slightly out of tolerance, bending something. And that's just, it further compounded the issues that we were having with this line. So now, not only do you need to have a machine that needs everything to be perfect, now the machine itself is slightly less than perfect before the jam. And then, of course, there was the whole cleanup aspect of it. You can't just let the product sit in the machine. A couple of reasons. One, give it a few days, and that machine is going to absolutely reek. Remembering that we're working in food and beverage, so there is a food product in these cartons. So if you let that sit there and just uh, rot on this machine, it's going to smell absolutely terrible. The second one is if you get product on the sensors could potentially start giving you weird readings, or they could stop working altogether. And with this machine being the way that it was, there really was no interface. There was a stack light that told you whether it was running or faulted, but that's it. So every time something would get out of whack with it, you wouldn't know. So you had to be really careful with making sure that you cleaned all of the sensors and everything. So after every jam, after you finally got the cartons out of the way, you would have to spray the whole machine down, and then you would have to go through the machine and find every sensor, wipe it down, just checking through everything to make sure you don't have product on anything, and then you got to wipe off all the water as well. So we're not just talking a couple of minutes to clear a jam and clean a machine up. We're talking like 10 to 15 minutes of downtime every single time we had something happen. So that in itself wouldn't have been too bad, but the brutal part was that the world really didn't wait for them. So there were so many times where the operators would just finish getting everything cleaned up and get it all buttoned up, start the machine, and another carton would explode. And I cannot even begin to explain how demoralizing that is. You just spent 10, 15 minutes cleaning this machine, and we go to restart this machine, and now you're back exactly where you started without even getting to catch your breath, really. So I think if I haven't described it well enough, let me give you the overall vibe of this line, because there's one detail of this line that I always found funny, because this is the line that it happened on. So in the middle of this project, our vendor was switching from a C series to a D series photo eye, and normally that doesn't matter, uh, except for this time. With this particular change, they dramatically increased the LED brightness on the back of the sensors. So we ended up with like half the photo eyes on this line having the Series C, which was the dimmer LEDs, and then the other ones were the insanely bright ones. So nothing was wrong with them. They both worked perfectly fine, but visually you'd walk down the conveyor and it just looked ridiculous. Like half the line was normal, half the line was lit up like they're like a Christmas tree on the back of every sensor. So it was technically correct. It was fully functional. It was really obviously mismatched, which basically was kind of the motto for the entire line. So I think one of the big things that people don't fully understand about being the integration controls engineer on a project like this is that you're the person standing there. So when something goes wrong, and on this line there truly was always something going wrong, you're the one who's physically present, and it doesn't matter whether it was your fault or not. You're there, so you're the target. I can just think back of so many different interactions with the operators where they would both blame me and understand it wasn't me. And sometimes it was in the same conversation. And here's the thing. Sometimes it actually was my fault. The back pressure was something that I had to figure out through trial and error on this machine. We we were trying to keep this line relatively compact, and because we made that decision, again, because it was temporary, it actually created a lot of complexities with trying to manage that back pressure because there wasn't a whole lot of conveyor to play with. So, again, this is where everything had to be really perfect for this machine. And you know, being that person that, you know, I watched the operators. They just went through. They spent the last 15 minutes cleaning up the machine, and then I'm going to make some changes, and we're going to start back up. And oops, there's another carton that just blew up, and now they have to clean it up again. At this time, I'm still that young engineer, and I'm watching grown adults go through all this craziness because of a mistake that I made, and that was kind of hard. I tried not to take it too personally when people would blow up and start yelling, because I knew, like I said, it wasn't always my fault, but at the same time, I also knew that sometimes it was. And holding both of those things at the same time when you're a young engineer still trying to figure out what you're doing it's hard. I can't tell you how many times I grabbed a spray bottle and tried to help clean up, and how many times I wiped down the photo eyes, and it's not because it was my job, because it really wasn't, but because standing there with nothing to do while the operators had to clean up a mess that I might have caused, or, probably caused, just felt wrong. So here's the thing about a project like this that actually took me a long time to understand. With software, you can always fix the software. If something is going on in the code that's wrong, you can go back in and you can make a change. You can make the issue go away. And that was the domain that I was really strong with. The problem with this line was that most of what was going on wasn't a software problem, it was a mechanical problem. Actual physical things misbehaving. And my understanding of mechanical problems at this point was nowhere near as strong as my programming understanding. I think the best analogy that I can use to describe it was, I felt that I had all these problems that required a screwdriver, but all I had available was a hammer. And my hammer was the software side. I knew it well enough. I could make the changes there all day. But at the end of the day, I still needed a screwdriver. And there was no amount of code changes that was going to make this line magically better. And on top of that, being a young engineer means that nobody automatically trusts your read on the situation. I remember going to the mechanical guys who'd been doing this for years and saying, "Hey, I think this is a mechanical problem, not a controls problem." And their immediate reaction was pretty much always, "No, It's you. It's a programming problem. So now you're not just trying to fix the problem, you're also trying to convince people there is a problem in the first place. And that gets tough. I remember going back to the hotel so many days and just staring at the ceiling like, this sucks. I don't know how to do this. And, it created this real amount of self doubt that I carried around for a while, which, again, if we're looking at it in contrast to the line in episode 5, where, everything seemed really cool, it's such a crazy like whiplash moment. But here's where I am now looking back at all that. You know, I don't really feel sorry for, you know, the me that had to go through all of this. I can remember how draining all of this was. I can remember the emotions. I can remember like how everything felt during this project, but I can also look back now and see that everything I went through on this crappy little temporary line really helped shape a lot of, how I am as an engineer today. I always hated the phrase, you learn more from failure than success. It sounds like something you'd put on a motivational poster, and I just it's hard to look at it like that, but it's actually true. You know, again, if I contrast how the line in episode 5 went, where everything went really well, I had a plan, I executed it. Yeah, sure, I had to go through a bunch of stuff to get it perfect, but there was a path there. But on this line, it was just it was failure after failure after failure, and I actually learned a lot from this line that I wouldn't have had it all gone perfectly fine. Uh, so, I mean, because of that line, I had to learn a lot of the mechanics of how these systems actually function, and it really helped push me along in my career and became a core part of how I work now. I can look at a machine and understand it from a controls standpoint, but I can also look at it and understand mechanically what's supposed to happen. And I think that a lot of that mentality really started to develop when I was stuck on this crappy little temporary line where it wasn't software that could save me on a lot of the stuff. I think it is important to point out that not every project is elegant. Sometimes you're handed a pile of garbage with mismatched photo eyes, uh, pieces of machinery that, may or may not catch fire, and you just have to make it work. And, sometimes you do, sort of. But just because something runs doesn't mean it's good. Until next time, this is From the Bucket.